Hello there, 7th graders. This is Mr. Kashi speaking. As you can see, I can't be in class there today, but we'll go through the lesson here, and hopefully I'll be taking as many questions as I can on Monday when I return. So, our schedule for the day is as it appears on the board. We'll correct the homework real quick, and then we'll move right into our lesson on 3.7, which is on precision. And there should be plenty of work time today after the video. So, the three things that you need out are 1, you need pencil, 2, notebook, and 3, you need your vocab sheet out as well. I'll give you a little time to get that out here. So, pencil, notebook, vocab sheet. We're going to be talking about precision today. If there's any time throughout the class period that I'm moving too fast, just raise your hand, and the sub can pause the video, and they can resume it whenever you are ready. So pencil, notebook, vocab sheet. Hopefully you have that out, because that's usually what we need out every day. So correcting the homework. Here are the answers for them. Now, obviously, you do not need to do all of these. You just have to correct the ones that you chose to do in your homework. I put the odds in there as well, even though I told you to do evens. There are some people that go ahead and complete all of the evens and go and do all of the odds as well. So I will kind of scroll up, and once again, if we're moving too fast, you can have the substitute pause wherever you need to look at more answers. So even if you're not done with 9, 10, 11, 12, or whatever, I'm going to still scroll down here, and she can rewind it if you guys aren't ready to move that far on yet. But due to the length of the video, that I need to keep moving. All right. 3.7 is on precision. Okay. Simple question here, relating back to reviewing of yesterday, is which is the smallest unit? Now, we have 4 options here. These are all units of length: inch, yard, foot, and a 1/4 inch. Now, the smallest unit is up here is inch, but instead of just inch, we can break it down in even smaller than that if we want to break it down into increments of 1/4 of an inch. All right, this is the basis of precision. Precision deals with how big units are compared to one another. These are all units of length. Yard would be the largest, foot would be the next smallest, inch smaller yet, and then if we were to count in 1/4 of an inch, that would be the smallest unit that is on the slide. Moving on. Okay, I want to quick give you the definition of precision, give you a little note, and I want to give you an example about how I learned precision. And precision is kind of complicated. It's not as straightforward as a lot of other concepts are in math. But precision, the definition of precision that you need to put in your vocab sheet, is a grade of how exact a measurement is. A grade of how exact a measurement is. We're going to be going through multiple examples here. Because I am gone and it is such a hard concept, I'll be taking multiple questions when I return next week, because this is not an easy concept to really understand, even if I was there to answer all your questions. So, precision, a grade of how exact a measurement is. All right. And a little note below that, the smaller the unit, the more precise. Okay. The smaller the unit, the more precise. So, what I would like to do is, I'm going to put those away. I'm going to show you kind of an example of how precision works. Okay. So if we were talking about students in this classroom, okay. Well, students in this classroom, we could say that all the students are in Red Wing. Now, that's not very precise. Okay, the students are in what Red Wing, but so are a lot of other people. That's not very precise. So moving on, instead of Red Wing, maybe we'll say Twin Bluff Middle School. Now that's more precise. That's narrowing down. Where you are in the city, but still that's only getting to the school. It's still not very precise. So you're in Twin Bluff Middle School, but now we'll say now that you're in a 7th grade classroom. Now it's getting better, but we could narrow it down more. So 7th grade classroom. Well, which 7th grade classroom? Well, you're in Mr. Kashi's classroom. You're in Mr. Kashi's classroom. So each time that we've been doing this, the size has been getting smaller and smaller and smaller. Okay, so we have the city, we have the building, we have a group of classrooms, we have the specific classroom, and if you wanted to get more precise, you might even say which row or seat that you're sitting in the classroom. Okay, so we're going from very large to Red Wing. You could even go larger than that. You could go the state of Minnesota. You could go the country of the United States. So United States, Minnesota, Red Wing, Twin Bluff Middle School, 7th grade classroom, Mr. Kashi's classroom, row, and then seat. Okay, each one of those we get more and more precise. Okay, I would like to go over another example on this slide as well. Hopefully everybody has that down. If they don't, we can always rewind and make sure you get that down. Now, that would be an example on precision. Now, if we took all the students in this classroom and said their age, well, most of you would be 12 or 13. 12 or 13, one of those ages. Now, that's not very precise. That's only 2 ages that we're talking about. So if you can remember back when we were doing our birthday groups, like I believe it was probably the 2nd day, maybe the 1st day of class, we can't just say, oh, 12-year-olds over here, 13-year-olds over here. That they're too big of groups. We need to categorize them more precise than that. And so what I had you do is, instead of 12 or 13, I had you break up into the months that you were born in. Okay, and there was still some, when we broke it up into months, there were still too many people in one group and too many people in another. And so then not just getting in the order of the month, but we're getting the order of the days of the month. Okay, the days of the month, that's what matters. Okay, so we had 12, 13, we had the age, that wasn't small enough. Months still wasn't small enough. Days, and even in Jack and Megan and Sam Kelly's case, we had to not only talk about the day, but we had to talk about the hour of that day, and then even down to the minute. Okay, so this would be a measurement of time. Okay, how precise are we getting? Well, everybody is within the age of 12 or 13. Now, if we wanted to put you in order, 12 and 13, that's not very precise. But if we break it down to the months, more precise, even down to the days are more precise, hour, minute, and then if we wanted to go down to second, that would be getting almost too precise when we're ordering people by their age. Okay, so the smaller the time increment, the more precise that we get. Couple examples here. Okay, so out of the ones on the board, which is the most precise? Okay, so they're all mixed numbers, but if we take a look at these mixed numbers, we have 1/2, 1/3, 1/4, and 1/8. Okay, now the smallest fraction that's kind of added on to one of these whole numbers, the smallest fraction is 1/8. So because 1/8 is the smallest fraction, this whole mixed number is the most precise. Okay, so it's using the smallest increment, the smallest fraction, to compare itself to the others. A couple more examples. Now, there are some cases where you're going to be comparing two different quantities that have the same number. Okay, so in this case, they're the same number, but they're different. They're different units. So what if they are the same number but different units? Which one is more precise? Okay, so if they have the same number, we have 2.5 cups and 2.5 gallons. We have to go, we can't compare the numbers because they're the same. But if we talk about which one is more precise, cups is smaller than gallons, and so 2.5 cups would be smaller than 2.5 gallons. Just because cups is a smaller unit of measurement. Just the same way as ordering people by age, you can do that by days rather than by years. Okay, I wanted to show you how we can do this with a ruler as well. Okay, so if I were to take the difference between 4 and 2 right here, I would get 2 inches. Okay, 2 inches. That's down by the inch. Now, let's say that I do it between 4 and 2.5. Okay, now we're measuring by the 1/2 inch. That is a more precise measurement. Okay, 2 inches and 1.5 inches. Now, let's say we're talking about 1/4 inches. All right, 1 3/4 of an inch, because we're counting by 1/4 inches. 1 3/4 of an inch is more precise. Now, let's break it down even more. 1 5/8, that's even more precise because our denominator is getting bigger. The increment in which we count by eighths is more precise. And on this ruler, we can even go one more and go 1 9/16. All right. So the further that we go down with these, okay, the more precise we get. All right, so 2 inches is not very precise. That's down to the inch. But now with the 1 1/2 of an inch, it's a little bit more precise because we're counting by halves. And then down here we're counting by fourths, counting by eighths, counting by sixteenths. Okay, so the smaller fraction that we have, the more precise that our measurement is going to get. All right, we're going to skip that example for now. I really have to explain this one. This is probably the hardest part of this whole precision lesson. Okay, so 19 3/8 inches minus 5 inches. Okay, since there is no fraction over here, this problem gets a little bit simpler because we just have to do 19 minus 5. 19 minus 5 gives us 14. Now, a lot of you are going to say, well, 19 3/8 inches minus 5 inches is 14 3/8 of an inch. Okay? This is the hard part for a lot of 7th graders. Because this 5 inches is not as precise as the 19 3/8 of an inch, we can only round to the nearest inch. Just because 5 was only measured in inches, it was not measured in 1/8 of an inch. Okay, so because of that, we have to round to the nearest whole inch, and so we would round this 14 3/8 down to 14 inches because it is the smaller fraction.